This is SpaceTime Series 27, Episode 76, for broadcast on the 24th of June 2024. Coming up on SpaceTime, the earliest evidence of fresh water on planet Earth. New evidence showing the rotation of planet Earth's inner core has slowed down, and how planet Earth's encounter with interstellar clouds affected its climate. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have discovered evidence that the earliest fresh water existed on planet Earth about 4 billion years ago, and that's some 500 million years earlier than previously thought. The findings, reported in the journal Nature Geoscience, are based on samples of rock collected from the famous Jack Hills Formation in Western Australia's Midwest, which is among the oldest geology on Earth. The study's lead author, Dr. Hamid Gamal El-Dien from Curtin University and the Khalifa University in the United Arab Emirates, says the discovery is significant because it pushes back the time frame when life could have first appeared on the planet to just a few hundred million years after the planet's formation 4.6 billion years ago. Gamal El-Dien says the discovery allowed him and his colleagues to date the origins of the hydrological cycle, the continuous process through which water moves around the Earth and which is crucial for sustaining ecosystems and supporting life. The authors reached their conclusions after analysing ancient zircon crystals dating back some 4 billion years, which were extracted from the Jack Hills rock samples. Zircons act like tiny time capsules, allowing scientists to date the origins of the crystal. By examining oxygen isotopes in the zircon, they found a high proportion of unusually light oxygen-16 isotopic signatures. Gamal El-Dien says oxygen-16 isotopes are typically the result of hot fresh water altering rocks several kilometres below the surface. Evidence of fresh water this deep inside the Earth challenges the existing hypothesis that Earth was completely covered by oceans 4 billion years ago. You see, as the fresh water was evaporated from the ocean by sunlight, it would have formed clouds, which eventually rained down onto dry land, where it soaked down into the ground, thereby preserving its freshwater status and preventing it from simply falling back into a salty ocean. The study's co-author, Dr. Hugo Olleruck, also from Curtin, says the discovery was crucial for understanding how the Earth formed. It not only sheds light on Earth's early history, but also suggests that fresh water and land masses set the stage for life to flourish within a relatively short time frame, less than 600 million years after the planet formed. Gamal El-Dien says the findings mark a significant step forward in science's understanding of the planet's ancient history.
The story started when I was looking for some paper, started to know about the early life and how the early life start. I found some papers talk about the life that starts around 3.5 billion years ago. And this is life started as a single organism. And by the way, it's already found in Western Australia, also in some rocks preserved in some place in Western Australia called the Pilbara, in north of Western Australia. So we now have 1 billion year gap between the start of the formation of the Earth and the start of the life to form. So why we don't have a life in this 1 billion years? To have a life, and as agreed between the scientists, this life to start in the presence of fresh water and land. So, there are fresh water before 3.5 and the land above the sea level or not? We don't know. So, how we can know this information? To know this information, we need to find some geological record to study to know this information. The only thing we have and already preserved in the earth to know information about this very old age, it's Jack Hills place in Western Australia. Why Jack Hills? Because Jack Hills have some zircon, have dated back to 4.4 billion years ago. So just around 100 million years after the Earth is formed. So why we need to study the zircon? Because zircon has three advantages. The first thing, zircon can keep the information and not destroy within time, within physical and chemical change. The second thing, zircon has uranium and lead. So we can use uranium and lead to date the zircon and know exactly the age of this zircon. The third thing, the zircon have oxygen. And oxygen is the main thing, as we know, in the composition of the water, because water is H2O. So we have O, which is oxygen, found in zircon and found in water. We know that oxygen has two main or three isotopes, 16, 17, and 18. And the two most common one is 16 and 18. We have two types of water, salty water, which is found in ocean, and the fresh water, which is coming from the rain. So what is the difference between both? The both have different oxygen isotope composition. The ocean or salty water have oxygen 18, which we call the heavy oxygen. And the fresh water have oxygen 60, which we call light oxygen. So if we measure oxygen 16 and oxygen 18 in zircon, because zircon is already have an oxygen in its composition, we can know about the water was found at the age of the formation of zircon. And this is exactly what we did. We go to Jack Hills, we collect new samples, and we started to separate zircon from this sample, and we did a lot of measurement. We spend months to do it. So to imagine how the effort and time, we do around 1,400 analysis, and this is 3 times more analysis than what done before in 30 years. We spend a lot of time to do that. And what we found around 4 billion years ago and around 3.4 billion years, we found our zircon have oxygen 16, have more oxygen 16, a lot of oxygen 16. And if you have oxygen 16, as we mentioned in the beginning, you should have some signature of fresh water. So in this case, around 4 billion years, you should have some fresh water. But how this fresh water is found? You can't have a fresh water without a land above the sea level, because if you don't have a land and you have rain, the rain is going down to the ocean and salty water. So in this case, we can't define or we can't keep this fresh water. So from our data, we can say two things. The first thing, we have a fresh water, and consequence for that, fresh water should be found in the land above the sea level. So from our new results, we can pinpoint 2 new discoveries. The first one, we found a fresh water through zircon analysis around 4 billion years. And from this fresh water, to have a fresh water, you should have a land above the sea level. And this is not defined or not known to the scientists before. All the scientists know the life maybe starts around 3.5. But now, guys, we have a fresh water. We have a land above the sea level at 4 billion years ago. So why not? We can push the line 500 million years back as the scientists thought. But now, do we have any evidence that life was developed at this time? Until now, we don't know. We should search for that. But at least we have the main ingredient that the life maybe start at this time. Should be the next step for us as a geochemist, for astrobiology, for paleontologists. We should look for more information that can help us to find if there are life around 4 billion years or not.
The next big question, I guess, is where did the water come from? Is it something that formed with the planet, or is it something that came afterwards? And for that, I guess we need to know the hydrogen to deuterium ratios.
All the scientists agree that the Earth, after it's formed by short time, the Earth was covered by water, by ocean. This is like salty water or oceanic water. And there are 2 theories explain that. One discuss about maybe the water is coming from asteroid or meteoroid. As you know, there are some asteroid built now around the Jupiter and the Mars, and this asteroid is highly enriched in hydrogen and oxygen and water. And this gives some hint to scientists to say, because the Earth has already suffered from meteorite impact and asteroid impact in the beginning of the formation, and the scientists expected that the waters come from outside and after that come to the Earth. This was the first theory. The second theory is that maybe the water, hydrogen and oxygen is already kept or locked within the mineral or magma composition of the Earth. And when the Earth started to form and we have outgassing and the volcanoes, this is started to go out and the hydrogen and oxygen interacted to form the water, and after that they form the ocean. But this is only explains the formation of the oceanic water and how the Earth is covered. But in our case, we mentioned that this is the first appearance or first evidence we have a fresh water. And from the fresh water we mention here, it's rainy water, because there is no difference in hydrogen between that or that. The difference is mainly in oxygen isotope. That's what when we found we have oxygen 16 is more higher in our oxygen, we say that, yes, this is rainy water. This is meaning fresh water.
That's Dr. Hamid Gamil Al-Dien from Curtin University and the Khalifa University in the United Arab Emirates. And this is Space Time. Still to come, a new study suggests the rotation of planet Earth's inner core is slowing down compared to the planet's surface, and how Earth's encounter with an interstellar cloud would have affected the planet's climate. All that and more still to come on Space Time. A new study suggests that the rotation of planet Earth's inner core is slowing down compared to the planet's surface. The discovery, reported in the journal Nature, follows earlier research over the past 2 decades showing that the core and outer planet, meaning the mantle and crust surface, seem to be rotating at different rates. Some researchers even suggested that the core is actually spinning faster than the surface. However, this new study provides unambiguous evidence that the inner core began to decrease its rotational speed around 2010, moving slower than the Earth's surface. The study's lead author, John Vidal from the University of Southern California, says he was stumped when he first saw the seismograms hinting at this change. But the discovery of 24 more observations signaling the same pattern have confirmed those initial findings. Vidal says it seems the Earth's inner core has slowed down for the first time in many decades. Other scientists have recently argued for both similar and different models, but this latest data provides the most convincing resolution. The inner core is considered to be reversing or backtracking relative to the planet's surface due to moving slightly slower instead of faster than the Earth's mantle for the first time in approximately 40 years. So, relative to its speed in previous decades, the inner core is slowing down. The inner core is a solid iron-nickel sphere surrounded by a liquid iron-nickel outer core. Roughly the size of the Moon, the inner core sits almost 4,830 kilometres below sea level. But studying it presents a huge challenge for scientists because it can't be visited or viewed. Instead, scientists need to use seismic waves from earthquakes to create renderings of the inner core's movement. In contrast to other research, Vidal and colleagues utilised waveforms and repeating earthquakes to determine what was happening. Repeating earthquakes are seismic events that occur at the same location, producing identical seismograms. In their study, the authors compiled and analysed seismic data recorded around the South Sandwich Islands from 121 repeating earthquakes that occurred between 1991 and 2023. They also utilised data from twin Soviet nuclear tests between 1971 and 1974, as well as repeated French and American nuclear tests from other studies of the inner core. Vidal says the inner core's slowing speed was caused by the churning of the liquid iron outer core that surrounds it, which generates Earth's magnetic field, as well as gravitational tugs from denser regions of the overlying rocky mantle. Right now, the implications of this change in the inner core's movement for the Earth's surface can only be speculated. the backtracking of the inner core may ultimately alter the length of a day. But right now, that would likely be in the order of just a thousandth of a second, a time frame almost lost in the noise of the churning oceans and atmosphere. The next challenge will be to try and chart the trajectory of the inner core in even greater detail in order to try and determine exactly why it's slowing down. This is SpaceTime. Still to come, how Earth's encounter with interstellar clouds affected the planet's climate. And later in the science report, a new study shows China's nuclear weapons stockpile is growing faster than any other nation. All that and more still to come on SpaceTime. A new study has found that our solar system may have passed through dense interstellar clouds 2 billion years ago, altering planet Earth's climate. The findings, reported in the journal Nature Astronomy, suggest that this cloud formation was so dense that it could have interfered with the sun's solar wind, the constant stream of charged particles flowing from the sun and filling our solar system with a heliosphere. Around 2 million years ago, planet Earth was a very different place, with our early hominid ancestors living alongside saber-toothed tigers, mastodons, and enormous rodents. And depending on where they were, they may have also been very cold. You see, at this time, Earth had fallen into a deep freeze, with multiple ice ages coming and going until around 12,000 years ago. Scientists theorize that ice ages occur for a number of reasons. These include the planet's tilt and rotation, changes caused by shifting tectonic plates and volcanic eruptions, and as we're seeing now, changes in carbon dioxide levels in the atmosphere. But what if drastic changes like these are not only the result of the Earth's geology and environment? In this new study, lead author Merav Ofer from Boston University says the Sun's location in galaxy space may also shape Earth's history more than previously thought. The solar system is bathed in a protective plasma shield that emanates from the Sun, known as the heliosphere. It's made from the constant flow of charged particles called the solar wind, which stretch well past Pluto, bathing the planets in what NASA calls a giant bubble. Importantly, it also helps shield the planets and life on Earth from radiation and galactic cosmic rays that could alter DNA. In fact, some scientists believe it's part of the reason life evolved on Earth the way it did. Now, apparently, a cold cloud compressed the heliosphere in such a way that it briefly placed Earth and other planets in the solar system outside of the heliosphere's influence. Ofer says her paper's the first to quantitatively show that there was an encounter between the Sun and something outside the solar system which would have affected Earth's climate. Her models have already quite literally shaped science's understanding of the heliosphere and how the bubble is structured by the solar wind pushing up against the interstellar medium. That's the space beyond the heliosphere between star systems in our galaxy. Like most other objects in the Milky Way, the Sun orbits around the galactic center, taking around 230 million Earth years to complete each galactic year. And in this process, it also moves up and down through the galactic disk. As it does so, the heliosphere is shaped like a big puffy croissant, with the Sun pushing the leading edge like a bow wave through interstellar space. And of course, where the Sun goes could affect Earth's atmospheric chemistry. To study this phenomenon, Ofer and colleagues used sophisticated computer models to visualize where the Sun would have been positioned 2 million years ago, and with it, the heliosphere and the rest of the solar system. They also mapped the path of the local ribbon of cold clouds, a string of large, dense, very cold clouds, mostly made of hydrogen atoms. The simulations they arrived at showed that one of the clouds close to the edge of that ribbon, named the local lynx of cold cloud, could have collided with the heliosphere. Ofer says that had that have happened, Earth would have been fully exposed to the interstellar medium, where gas and dust mix with leftover atomic elements from exploded stars, including iron and plutonium. Now, normally, the heliosphere would filter out a lot of these radioactive particles, but without protection, they can easily reach the Earth. And it's not just hypothesis. This idea aligns with geological evidence showing increased levels of iron-60 and plutonium-244 isotopes in the ocean, on the Moon, in Antarctic snow and ice cores, all dating back to the same period 2 million years ago. And the timing also matches with temperature records indicating that Earth went through a cooling period back then. The study's co-author, Avi Loeb from Harvard University, says only rarely does our cosmic neighbourhood beyond the solar system affect life on Earth. He says it's exciting to discover that our passage through dense clouds a few million years ago could have exposed the planet to much larger fluxes of cosmic rays and hydrogen atoms. These results open a new window into the relationship between the evolution of life on Earth and the cosmic neighbourhood. Ofer says the outside pressure from the local links of cold cloud could have continually blocked out the heliosphere for a couple of hundred to more than a million years, depending on the size of the cloud. But as soon as planet Earth was away from the cold cloud, the heliosphere once again engulfed all the planets, including the Earth, and that's how it is today. Of course, it's impossible to know the exact effect the cold clouds would have had on the Earth, such as whether or not it could have spurred an ice age. There are a couple of other cold clouds in interstellar space that the Sun likely encountered during the 4.6 billion years since it was born, and it will likely stumble across more in the next million years or so. So the authors are now working to trace where the Sun was 7 million years ago, and they then want to go back even further. Pinpointing the location of the Sun millions of years into the past, as well as the cold cloud system, will be possible thanks to data collected by the European Space Agency's Gaia mission, which is building the largest 3D map of the galaxy, giving astronomers an unprecedented look at the speed and direction in which stars are moving. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study warns that China's nuclear weapons stockpile is growing faster than any other nation, increasing by nearly 100 warheads over the past year alone. The Stockholm International Peace Research Institute's annual report on international security says Beijing's nuclear arsenal has grown from 410 warheads to more than 500 during 2023. The Institute added that while China's stockpile is expected to keep growing, it's also deploying more warheads on its missiles. The report comes as China continues to move politically closer to Moscow. Russia's invasion of Ukraine, China's continuous harassment of Taiwan, the Philippines, Japan and India, and Iran's never-ending attacks on Israel using their Palestinian Hamas and Hezbollah puppets in Gaza and Lebanon are raising growing concerns of conflicts going global and possibly even turning nuclear. According to the Institute, of the world's estimated 12,000-plus nuclear warheads, more than 9,500 were in military stockpiles for potential use, with an estimated 3,904 being deployed as of January, and that's an increase of 60 from a year earlier. Current estimates suggest Moscow has the largest nuclear weapons stockpile, with 4,489 nukes. That's followed by the United States with 3,708, China with around 500, France with some 290, the United Kingdom with 225, India with 172, Pakistan with 170, and North Korea with at least 50. Israel neither confirms or denies the existence of a nuclear weapons stockpile, but estimates suggest that Jerusalem has between 90 and 210 thermonuclear devices. Paleontologists have identified a new species of sauropodomorph dinosaur in Zimbabwe. Unlike the quadruped sauropods, which feature elephant-like bodies and legs with a long tail at one end and long necks and small head at the other, like Fred Flintstone's pet Dino, sauropodomorphs appear to only walk on their hind legs, using their forelimbs more like arms and hands. The 390-kilogram dinosaur, which dates back some 210 million years to the late Triassic, was identified through the remains of a single hind leg, including its thigh, shin and ankle bones. The herbivore's discovery represents only the fourth dinosaur species found in Zimbabwe. Named Musanquasanyatensis, the new species has been described in the journal Acta Paleontologica Hollandsia. A new study suggests that people who are paranoid often tend to think that other people have similar beliefs to them. The findings, reported in the Journal of the Royal Society Open Science, consisted of setting up online games involving 165 people whose paranoia levels were assessed based on their political, scientific, religious, paranormal and moral beliefs. Participants then played the games, which involved sharing money in pairs, and each participant was then asked to assess whether or not they thought their partner shared their beliefs. How paranoid people were and the degree to which they felt their partners shared their beliefs didn't affect their performance in the game. But researchers were able to find that people who scored highly for paranoia were also more likely than those who were less paranoid to think that their partner shared similar beliefs to them. A spectacular fireball travelling over France, Spain and Portugal recently highlighted an interesting phenomenon. Why is it that dozens of sharp, clear images and videos of the meteor streaking across the sky can quickly be posted online, and yet you can never get similar quality videos and images of UFOs or other paranormal events? In other words, why are those always blurry? Tim Mendham from Australian Skeptics says it's a question which has long been pondered by many in the skeptical community.
In 1972, in August, there was something called the Great Daylight Fireball, which went over Middle America, by Middle America, the central states of the USA, and it was visible for less than 2 minutes, probably a lot less, and yet people managed to get photographs of it, including a couple of movies, and this was the days before mobile phones. This is when someone happened to have a camera ready and pick it up and film this thing, and yet the suggestion was that if hundreds of these people can photograph this thing, when it comes over without any warning and it's fleeting, how come we can't get good UFO photos, which tend to hang around a bit more? They're always fuzzy, etc. This recent thing was it's actually part of a comet. Everyone keeps calling it a meteor, but it's actually part of a comet which travelled over France, Spain and Portugal, especially Spain and Portugal, and it was probably in the sky for about 2 seconds, maybe 3 if we're being generous. It was at night and it was very bright and it lit up the surrounding areas and lit up the sky, certainly, so people were, wow, sort of really surprised by it. But the fact that they managed to film it, and it's filmed on people taking, it was social events, people filming a friend and suddenly this thing flies over, so they move the camera up and film that. Look great. Dash cams were filming it, security cameras on buildings, traffic cameras, and all these things recorded this thing very clearly for a fireball. And yet at the same time, this is flying at, yes, I said, a couple of seconds. It's flying at 160,000 kilometres an hour and at 60 kilometres height. Now your average UFO is flying at a lot less speed than that, probably a lot closer to the Earth. Sometimes people talk about meters rather than 60 kilometres. And they sit there or they hang around or they move slowly, whatever. And the films, for some reason, are always fuzzy, always shaky. These films of the fireball were actually pretty good, pretty steady, especially as there's so many cameras around these days. Anywhere you can hardly move without being spotted by a camera. And yet UFO photos are still a problem, still sort of really not very good at using evidence at all, whereas this fireball was plainly obvious, filmed so many times, as was the Great Daylight Fireball of 1972, before the days of everyone carrying a high-resolution video camera in their pocket. So it's a contrast. Great sight, very spectacular. You look at the videos online, you get a lot of them that are available online, and it looks fantastic. A lot of people managed to film it. And why can't we do the same with UFOs or Bigfoot or abominable snowmen or whatever? I mean, you know, it's just the contrast is actually quite telling. When you have a longer look at a Bigfoot or a UFO, you have a fleeting, very fleeting look at a fireball, and yet there's more films of that than there is of the monsters or the flying saucers.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to Space Time with Stuart Gary. This has been another quality podcast production from Bytes.com.